Hello, this is Mr. Huber. In this lesson, we're going to look at solving radical equations. We have some basic steps here we want to be able to follow and solve radical equations with. So pay attention to how we're going to isolate radical expressions on one side of the equal sign. So it's like getting the variable by itself, but now we're going to get a whole radical expression by itself. Then we're going to raise each side of the equation to the same power that will eliminate the radical. Okay, so we're going to raise each side of the equation to the same power. Whatever you do on one side, do the same thing on the other side. And then we're going to solve the equation that's left over without the radical in it anymore. So let's see how we can use these three steps here in this first example. So we've already got the radical expression isolated by itself. Okay, the radical expression is this whole square root of x plus 25. There's nothing else multiplying it or outside of the radical. We got the radical by itself, so now we want to get rid of the square root. So the opposite of square root is squaring. So we're going to square both sides of the equation. That's going to give us x plus 25 equals 9. Okay? And then I can subtract 25 on both sides and end up with x equals negative 16. We want to check that. Okay, well, if we're going to check that, we would plug it back into the original equation. So we're going to have the square root of negative 16 plus 25. That's the square root of 9, which equals 3. So it checks out and works. We're not always going to have the radical expression by itself isolated already. So we see a couple examples here where we're going to have some work to do before we raise both sides to some power. In this first example, what we want to do is add 5, or should say next example, it's our second one. We add 5 to both sides so that I get the cube root of x equals 4. Now I've got the radical expression by itself. Here, my radical expression, it's a cube root now, all by itself. The opposite of a cube root would be cubing. So now I'm going to take both sides and raise them to the third power. So the cube root and the cubing cancel out, and I have x equals 4 to the third power, which is 64. X equals 64 would be my solution. I could plug it back in, and I can check and make sure that it works. One thing to note here is that recall that third root of x is the same as x to the 1/3 power. So when we're raising that to the 3 over 1 power, raising it to the reciprocal of whatever radical we had there. Okay, the 1/3 power, the reciprocal, that would be 3 over 1. We're going to see where that will be useful in this next example. First, before we talk about the radical part, we're going to divide by 4. Divide by 4. That cancels out. We'll have x minus 3 to the 2/3 power equals 25. So this is where we want to recall what I just showed you with that 1/3 power and raising it to a reciprocal. So now I can raise that 2/3 power to the 3 over 2 on both sides. Right, 2/3 times 3 over 2. When we take a power to a power, like we have here, power to a power, we're multiplying 1/3 times 3. That's why it cancels to give us x to the first. Here, 2/3 times 3/2. We have a power raised to another power. They will cancel each other out because when we multiply them, they're going to become 1. So I would end up with x minus 3 equals 25 to the 3/2 power. Okay? Let's just keep it like that for a second. 25 to the 3/2. Okay, that's the same as x minus 3 equals, now we want to recall what we know about rational exponents as radical expressions, the square root of 25 to the 3rd power. That's going to be x minus 3 equals the square root of 25, which is 5 to the 3rd power, 125. Now I can add 3 to both sides, to cancel that out, and get x equals 128. If we want to check that now, we put it back into the original expression, 4, and then we have 128 minus 3 to the 2/3 power. This would be 4 times 125 to the 2/3 power. If you recall, we need to do exponents before we multiply, so we need to do 2/3 power. That means the third root of 125, which is 5, and then squared. So this is the same as 4 times 5 squared, which is 25. That comes out to 100, which in fact equals the 100 that we had. 100 equals 100. So it checks when we look at it and make sure that it works. X equals 128 would be our correct answer. Before we see a couple other examples, Google, which we use all the time as a term and the website to search things and whatever else we use that Google has helped us with over the years, they named that for a mathematical reason. There's a mathematical term that the company Google named itself after. It's a large number with 100 zeros. A Google, spelled a little differently, Googol instead of LE, is a 1 followed by 100 zeros. And that Google is where Google named itself. All right, let's see a couple other examples and things you may want to try on your own, see how you're progressing with these, getting the radical expression isolated by itself, and then solving for the variable. So first example, we're going to subtract 8 on both sides. So that's going to be 3, and then square root of x minus 2 equals 12. We need to subtract the 8 on both sides, and then divide by 3. That gives us the square root of x minus 2 equals 4. Now we've got this radical expression by itself, right? It's just the radical, nothing multiplying it like the 3, nothing adding or subtracting outside of the radical. We don't want to add 2 to both sides now, because that minus 2 is inside the radical. It's part of the radical expression. Okay, so what we can do next is take both sides and square them. Okay, the square root and the squaring cancel out, and we get x minus 2 equals 4 squared, which is 16. I can add 2 to both sides and get x equals 18. Again, you should get used to checking these. You should plug it in right now. Make sure you get 20 on the left side equals 20. Know how to check your answers. So if you get answers that are incorrect, you'll know and be able to figure it out on your own. In this next example, number 5, and if you want to pause and try it and see how you're doing, and compare to how the way I do it, we're going to divide by 3 on both sides first. We're going to get x minus 5 to the 3/4 power equals 8. Okay. Keep in mind that 3/4 power, that's like our radical part here. Now we have the radical expression all by itself. X minus 5 to the 3/4. You could write that as a 4th root and then to the 3rd power if you want to write it as a radical yet. I'm not going to do that yet because it's easier, I think, to eliminate that 3/4 power by raising it to its reciprocal without seeing it as a radical. So I'm going to raise it to the 4/3 power on both sides. Okay? So that cancels out, and I'll have x minus 5 equals 8 to the 4/3 power. That's x minus 5 equals the cube root of 8 to the 4th power. Cube root of 8 is 2, so this is going to be x minus 5 equals 2 to the 4th power, which is x minus 5 equals, again, 2 times itself 4 times. It's not 8. It's not 2 times 4. It's 2 times itself 4 times, which is 16. And now, and add 5 to both sides and get x equals 21. Okay. So know how to isolate the radical expression or the expression to a fractional exponent, how to work with eliminating then those radicals or fractional exponents to get those equations you can solve. And be sure to get in the habit of checking those answers, plugging them back into the original equation, always the original one, so you can see if the answer you got is right. And if not, find where you may have made a mistake that you can go back and correct.